Welcome to a video about types of vector databases. After watching this video, you will be able to categorize popular vector databases based on their types, capabilities, and vendors. Contrast the functions and characteristics of dedicated vector databases with databases that support vector search. And identify popular vendors of dedicated vector databases and databases that support vector search. As the name suggests, in-memory vector databases store vectors directly in memory. This approach enables swift read and write operations, making these databases ideal for applications that require rapid access to data, including real-time analytics and recommendation systems. In-memory database vector databases include Redis AI and TorchServe. For example, Redis AI is an in-memory vector database that supports storing and querying vectors for tasks like similarity search, classification, and clustering. Next, disk-based vector databases store vectors on a disk. This method suits large datasets that exceed memory capacity. These databases employ sophisticated indexing and compression techniques to enhance storage and retrieval efficiency. Disk-based vector databases include Anoi, Milvus, and Scan. As an example, Anoi, which stands for Approximate Nearest Neighbors Oh Yeah, is one database in this category. Anoi stores vectors on disk and constructs indexes for quick retrieval applications. Anoi reports that it's built for fast approximate nearest neighbor searches and is ready for recommendation systems and information retrieval applications. Distributed vector databases spread vector data across multiple nodes or servers. Distributed vector databases provide horizontal scalability and fault tolerance, making these databases suitable for managing massive datasets and high-throughput tasks. Distributed database vendors include FICE, Elasticsearch with Vector Plugin, and Dask ML. One notable example is Facebook AI Similarity Search, or FICE, which is a distributed and optimized database designed for similarity searches in high-dimensional spaces and partitioning data across nodes to achieve scalable and speedy searches. Graph-based vector databases model data as graphs, with nodes and edges representing vector attributes or embeddings. These databases excel in capturing complex relationships and facilitating graph analytics. Graph-based vector database vendors include Neo4j, Amazon Neptune, and TigerGraph. For example, Neo4j is a graph-based database that supports storing vectors as node properties or attributes. Neo4j allows queries and vector data analysis within the context of a graph. Neo4j capabilities support social network analysis, recommendation systems, and knowledge graphs. Next, let's learn about time series vector databases. Time series vector databases manage data collected over time intervals and represent this data as vectors. These databases serve as robust tools for analyzing temporal patterns and anomalies. Some notable databases in this category include InfluxDB, TimescaleDB, and Prometheus. InfluxDB, a vendor in this space, allows vector storage alongside time-stamped data. This capability enables querying and analyzing time series vectors to detect patterns, forecast trends, and monitor system metrics in IoT, monitoring, and anomaly detection applications. Next, let's contrast dedicated vector databases with databases that support vector search. They are different from each other. Let's learn more. As the name suggests, dedicated vector databases are systems that use their own special characteristics and optimizations to store, index, query, and analyze large amounts of vector data quickly and accurately. Similarity search, clustering, and classification work more efficiently using vector databases. Next, discover the essential characteristics of dedicated vector databases. First, to store and retrieve vectors quickly, dedicated vector databases often use unique data structures like reversed indexes, product quantization, and locality-sensitive hashings, or LSH. These databases support vector operations like nearest neighbor search, similarity search, and distance calculations, which lets users do complex searches on vector data. Dedicated vector databases are made to be scalable so that users can store and query big vector datasets quickly across clusters or distributed systems. These databases put speed first, using optimized algorithms and data structures to get quick answers to queries, even for vector data with a lot of dimensions. And users can change the parameters for indexing and searching to get the best results for certain use cases or types of data. Some currently popular dedicated vector databases include FAISS, Facebook AI Similarity Search, Annoy, Approximate Nearest Neighbors Oh Yeah, and Milvus. Next, in contrast, let's examine how other database technologies support vector search. Databases that support vector search are either regular database systems or data processing frameworks that let you store and query vector data. Even though these databases may not be made for vector operations, they have tools or add-ons that let users perform vector searches along with other types of queries. So, what characteristics are important for these databases? These databases let users store vector data as part of their data model. This data can be stored as blobs, arrays, or user-defined types, or UDTs. Some databases let you organize vector data using standard or custom index structures. This makes it easy to get vectors based on metrics like similarity or distance. Many databases have add-ons or integrations that let users take action on vector data using special libraries or plugins. For example, when performing similarity searches or other vector-related tasks, users can use external tools. Though these databases allow vector search, they might not be as fast or as well optimized as dedicated vector databases. Users must consider functionality, performance, and scalability relevant to their needs. Here are some database vendors that support vector search. First, Single Store with Vector Database Processing works with IBM watsonx.ai. Next, Elasticsearch has its vector add-on. PostgreSQL includes its PostGIS add-on for vectors in space. MySQL has its own indexes for vector search. Redis AI performs vector functions in memory, and Apache MongoDB and Apache Cassandra support vector searching with flexible schemas. In this video, you'll learn that vector-based database types include in-memory, disk-based, distributed, graph-based, and time-based databases. Vector-based databases speed performance for recommendation systems, social network analysis, knowledge graphs, graph analysis, and other complex tasks. Dedicated vector databases use data structures, reversed indexes, product quantization, and locality-sensitive hashing (LSH) that provide scalability, deliver speed, and enhance customization. Popular database vector database vendors include FAISS, Annoy, and Milvus. Databases that support vector search are either regular database systems or data processing frameworks that let you store data as blobs, arrays, or user-defined types. And notable vendors that support vector search include Single Store with its support for IBM watsonx.ai, Elasticsearch, PostgreSQL, MySQL, Redis AI, Apache MongoDB, and Apache Cassandra.